RANDARRAY is modern Excel's go-to function for creating random values. It's a game changer, the very backbone of any simulation you can run in a spreadsheet. And in this video, I'm going to show you 13 powerful ways to use it, from beginner-level coin tosses to drawing names out of a hat, right through to advanced tricks to cook up realistic data. Keep watching, and you'll also get a surprise self-test to sharpen your RANDARRAY skills. This is Excelopithecus Function Focus. The RANDARRAY function can take up to 5 inputs as settings. All of them are optional. If you create a formula with an empty RANDARRAY, it generates a single number between 0 and 1, just like the old school RAND function. The first input, rows, sets the number of values you want the formula to spill out vertically. If you leave it empty, the default setting is 1. The second input, columns, does the same thing for the horizontal spill dimension. I don't use this one very often, but it's good to know that it's there. If you leave it empty, the default setting is also 1. The third and fourth inputs set the minimum and maximum numbers the RANDARRAY is allowed to generate. If you leave these empty, the default range is 0 to 1, which is good for probabilities and percentages. The fifth and final input is called integer. If you fill it with true or 1, it tells RANDARRAY that you want whole numbers only. If you keep it empty, RANDARRAY generates decimals that run to 15 digits each. The numbers RANDARRAY spits out are uniformly distributed. This means that each number has an equal chance of coming up, including the minimum and maximum. The bigger the batch you generate, the closer it converges towards equality. That said, not everything in life is uniform. Later in this video, I'll show you how to make RANDARRAY generate random numbers with other distributions too. But let's start with the basics. For a heads or tails coin toss mechanic, open a RANDARRAY function, select how many tosses you want as rows or columns, skip the inputs 3 and 4, they're absolutely fine as they are, and set the integer to 1 or true. It will now spit out 1s and 0s with 50-50 odds. If you don't like 1s and 0s, you can nest the RANDARRAY inside an if function and type text into the result if true and result if false inputs. Because an if function can take numbers themselves as its logic check input, you don't need to type equals 1 after the RANDARRAY. What if you need something other than a 50-50 chance for something to happen? Like, say, a 70% chance. Get out RANDARRAY and fill the rows input. Then type a less than or equal condition after it, followed by a number between 0 and 1 for your probability threshold. In the results, you should get roughly that ratio of trues to falses. One thing this method is good for is tagging a dataset when you want it to do something to a random portion. You can use the rows function to get the number of rows in the data and use it as the RANDARRAY's first input. Be sure to paste the results as values, not as formulas, if you want them to stay permanent. You can extend the basic probabilities recipe with the OR function or AND function to simulate if a condition has been met after several tries. Imagine someone who has a 25% chance of hitting the bullseye on a dartboard. Will they hit it at least once if they throw 5 darts? Nest the RANDARRAY inside OR to simulate the trial and get an answer. Press F9 to repeat the test. Now, can they hit the bullseye with all 5 darts? Replace the OR with an AND, then watch the results. Are your colleagues tired of alphabetical order in team building activities? You can use RANDARRAY to give their names a fair shuffle. If the data is arranged vertically, use the rows function to find out how many rows it has, and feed that into the RANDARRAY. Then, use the sort by function with the data you want to shuffle as the first input, and your RANDARRAY as the second input. Because decimals generated with RANDARRAY have 15 digits, it's extremely unlikely that any two will be identical, so you probably won't need tiebreakers. To pull names out of a hat, start with the previous recipe for shuffling. You will need to nest it inside a new function called take. Take gives you back only the top or tail of your data. In the second input of the take function, type how many items you want to draw from the top of the shuffle stack. Because the RANDARRAY is only generating the sort order, not the final values, you won't get any duplicates that aren't in the data source. To generate random numbers that don't repeat, like, say, in a lottery draw, do the same thing, but nest a sequence function of the data inside the sort by function. You won't need the rows function, since you already know how many rows you're programming it with. In draws with replacement, or bootstrap samples, the same item can be picked multiple times. For this, start your RANDARRAY as normal by selecting the number of rows. In a scientific bootstrap sample, this should be the same as the number of rows in the original data, but not all draws of replacement need to follow that rule. Then, set the minimum number to 1 and the maximum number to however many rows the dataset has. Finally, set integer to true. You now have a random list of row numbers with repeats. The final step is to build an index function around it. For the first input, enter your data and leave the RANDARRAY as the second input. Voila! This technique works equally well with individual columns and entire tables. You can also clean up your formula by using a let function to assign the data a shorter name beforehand, say D, and the row count another name, say R, and then reuse them as shorthand in the final result. This recipe is great for cooking up dummy data, since you can take baby name lists and surname lists and spit out a whole army of Jane Does in seconds. If you want to generate a quick repeating list of randomly assigned categories, count how many categories you need. I'll be using 3 here for A, B, and C. Then, set RANDARRAY to generate whole numbers from 1 to your number of options. Finally, nest the RANDARRAY at the start of a choose function and type the category names after it as inputs.
We interrupt this RANDARRAY presentation with a surprise challenge. You have been dragooned into playing an obscure tabletop wargame that uses 7-sided dice in multiple roll attacks. This is where the pro Excel skills start. The year is 7000 AD. The 92nd French Empire rules the Milky Way, and a unit of star grenadiers is preparing to confront an uprising of cockroach-like aliens called Blatoidians. The bugs have repeatedly infringed the Empire's cultural policy by using regional dialects instead of standard galactic French.
In the face of such disrespect, la Grande Armée Galactique have no choice but to open fire with their antimatter muskets.
Let's roll some dice to see how many Blatoidians they remove from the table with 20 musket shots. The first step is the shoot roll, which starts with 20 dice. Any die that scores 4 or above has successfully hit one of the bugs, and goes on to the kill roll to see if it hurts its target. Dice results of 3 or lower are failures and ignored. However, the Grenadiers are under the heroic command of
Napoléon XIV,
whose mere presence on the battlefield makes their guns work better. He gives them a special rule: on their shoot roll they can re-roll die results of 1, and add successes to the kill roll as well. For the kill roll, any die that scores 3 or more removes 1 Blatoidian from the enemy unit.
Au Wever, le Blatoidian a render the command of le duc de Wellington, ou Brimison special rule.
For each bug killed, roll a die. If it's a 7, cancel the death and keep it in play. Your challenge: program RANDARRAY to follow all these rules and return the number of Blatoidian casualties.
The first problem to solve here is how to choose between the original die roll that RANDARRAY generates and the re-roll. In old school Excel, there was no way to do it in one formula. In the if function on the screen, Excel has no idea that one of the RANDARRAYs in the results is supposed to be the same one that it's testing in the logic check. If you use this formula, this would not give you a re-roll of 1s. Old school Excel had no solution for this except to use up spreadsheet real estate for cell references. In modern Excel, the let function can assign a name to your RANDARRAY and remember the results for the rest of the formula. Let's give the name shoot to the shoot roll and reuse it. We'll add a new step to the let function and call it re-roll shoot. This uses an if function to check if the result is a 1. If it is, it replaces the result with a number from a new RANDARRAY. Otherwise, it keeps the old result. Next, check which results from re-roll shoot are 4 or higher, and turn them into numbers with some dummy arithmetic. Use sum to count them up. I have another video on sum tricks if you'd like to know more. Now, use the sum result to determine the rows of the kill roll. Repeat this approach to check the successes on the kill roll and use the total as rows for the cancel death roll, which you'll subtract from the final result. With conditional probabilities, there's sometimes a chance that the previous RANDARRAY will have 0 successes, and setting RANDARRAY's row input to 0 will cause an error. So, as a fail-safe, use if error to return a 0 if that happens. Once you master let, you'll be able to handle any number of situations where probabilities depend on previous outcomes.
To test your new RANDARRAY skills, try to simulate the Blatoidian counterattack against the Star Grenadiers. The bugs who have survived the antimatter fusillade charge the Grenadiers with a vengeance. Their attack starts with 18 dice, all of which have 7 sides. First they must make a bite roll, which succeeds on 5 or more. Then, with a number of dice equal to their successes on the bite roll, they make a kill roll. The kill roll inflicts a casualty for each die that scores 5 or higher. Before combat, the Blatoidians have a choice of 2 upgrades to improve their chances.
Option 1, Drinking Radioactive Pastis sans a bug into a frenzy.
Each die result of 7 on the bite roll generates 3 kill dice instead of 1. Option 2, by sharpening their mandibles to be more lethal, the bugs automatically inflict a casualty on bite rolls of 7, without a kill roll. Use RANDARRAY and other functions to simulate these rules. Which upgrade removes more Star Grenadiers on average when you test both scenarios 10,000 times?
You'll find the answer at the end of this video. Bonne chance!
What would happen if we got our let function to show us the actual cancel death roll instead of the final casualties? You'll start to see spill errors randomly appearing. Here's why. When the row or column count of a spill array is determined by a random number, Excel has trouble keeping up with the array's current length. It needs to know that so it doesn't crash into cells you've already filled. To play it safe, it returns an error. You can fix this with the expand function. Expand increases the row or column dimension of an array to a fixed length and pads the extra cells with a value of your choice. Nest the variable length array inside expand, enter the maximum number of rows that the RANDARRAY could end up with, skip the columns input and set padding to return blanks. Now the function's stable. Spill cleaned. By themselves, uniform random numbers aren't accurate for simulating variables like height and weight. Those tend to form a bell curve when you graph them on a histogram. To generate normally distributed values, start with the default RANDARRAY that spits out probabilities. Nest it inside a norm_inv function as the first input. Then, enter the average you want, followed by the standard deviation. Voila! Instant normal distribution. The normal distribution isn't great for certain variables, often ones that measure money and time, like, say, days in hospital. Even if the average hospital stay was only 1 week, a few unlucky people might be hospitalized for months and months. Worse, the normal distribution allows negative values, but nobody can stay in a hospital for -11 days. To simulate this kind of thing properly, generate a log normal distribution instead. This uses the log norm_inv function, which works almost the same way as norm_inv. The only difference is you need to turn your source data into natural logs with the ln function before you calculate their averages or standard deviations. Also, you'd want to make sure your data can't have zeros or negative values, though fractions are okay. Now you're equipped to make Excel simulate the slowest waiting list in the universe. A random walk is the path made by a particle that changes distance and direction unpredictably. Let's start with one dimension of movement. Set up RANDARRAY so it's equally likely to return negative numbers as it is positive ones. Then, nest it in a scan function to make a running sum of its position. You want 0 as the first input and the RANDARRAY as the second input. For the third input, just type sum without brackets. On a line chart, you should now see a squiggle that looks like some sort of stock price thingy. To get 2D movement, drag and autofill your formula for a second axis and insert a scatter plot. Brownian motion is a special kind of random walk that uses normally distributed random movement instead. You can make this with the bell curve recipe I showed you earlier. Just make sure that the norm_inv function has an average of 0. There you go. Brownian motion. Long live the crazy squiggle. Do Dueling Idiots is a simulation problem described in a book of the same title by Paul Nayan, which I highly recommend if you want more puzzles to test with RANDARRAY. The problem goes like this. Two idiots, A and B, want to fight a duel, but they have only one revolver and one bullet between them. Their solution is a two-person game of Russian roulette. Each turn, one of the idiots spins the revolver, points it at their opponent, and pulls the trigger. If the chamber's empty, the other duelist takes their turn and does the same thing. You're supposed to simulate the game and check how often player A wins. This one's short and sweet. The revolver's a 6-shooter, so set RANDARRAY to generate whole numbers between 1 and 6. Give it 100 turns, because fewer than 1 in 80 million duels will go that long without a 6. Then, use Xmatch to find the position of the first 6 that appears. The number it gives you is the turn the gun goes off. If it's odd, it's player A's turn. If not, player B's the winner. So nesting it in the isOdd function will return true if A's the winner. Wait, but that's only one duel. How do you simulate it thousands of times? It's time to scale up. First thing to do is to make our Dueling Idiot simulation into a reusable custom function. Nest it inside the lambda function and that's it. There's nothing else. Lambda doesn't need inputs if your formula does the same thing every time and never uses outside references. You can now nest the lambda inside a let and assign it a name. We'll call it duel. Type duel at the end of the let function with a pair of empty brackets after it, and it runs the simulation. Maybe you can see where I'm going with this. Now, you just need a function that can run a formula again and again lots of times. Excel happens to have one called makeArray. Its first two inputs are rows and columns, which should be familiar by now. 1,000 will do. The third input is a nested lambda. It needs to have two inputs named, but you don't need to use them. Just plant the duel inside and close everything up. You'll get 1,000 duel results. Turn them into numbers with dummy arithmetic, average them, and there you go. Player A's chance of winning is about 54%. Thanks for watching and see you next time.